So in this class, we look into how to simulate the simple queues and revenue management problems. We first talk about learning objective. Then we look into the introduction of the queue, and then use a revenue management model to show how to use a scenario manager to actually do more sophisticated simulation. Last lecture, we have talked about how to construct simple simulation models and run multiple replications of simulation, and then interpret the results. So this lecture, we will focus on the specific or we see more complicated problems. So we'll simulate the QM models, and we use a scenario manager to analyze different scenarios. So scenario manager is a new thing in Excel we need to learn. Before we talk about how to simulate a queue, first let's see what is a queue. So here in this picture, we show a simple queue system. You can see the queue including the customers or the entities arrive to the system. So here arrive to the system, and so the very important characteristics for the arrival process is the statistical distribution of the arrivals, like how many cars will arrive into this service, and what is the inter-arrival time. And then in the system, so the characteristics is the queue discipline and the capacity, and also there is a service related characteristics. So here, very important, we would like to know the statistical distribution of the service. So the service time distribution, the customer arrival time, and after the service, the customers or the products will exit the system. So you can see this is a rather straightforward process. So you know your customer or entity base population, and then we're interested in the performance of the queue. So now you can see there are queues wait to be served. So we are interested in knowing how long this queue will be, and the waiting time of the customers. So this is an example of a queue. Most of queues actually look like the car washing process queues. In the literature, the queue normally is specified by different disciplines. So here, the queue discipline is typically specified using Kendall's notation. So here we use these different letters A, S, to show the different specifications. So we call it queue attributes. For example, we have a queue. The A shows the inter-arrival time distribution, like how much time between two sequential arrivals. S, capital S, service time distribution, normal distribution, exponential distribution, and so on. So M is the number of servers. So later on in the slide, in the handouts or in the lecture, we also use a small c actually to replace M. Capital B is the number of buffers. So how many cars, how many products, or how many customers are allowed to wait in the system. Capital K is population size. So SD is service discipline. For example, first come, first serve, last come, first serve, or different types. And sometimes it's a priority based service, and so on. since we actually assume the customer arrival process is M and this customer service time is also M, so we actually assume they are exponentially distributed random variables. So that's important. We know how to generate random values from, so generates random values from exponential distributions. First, let's see the probability density function of an exponentially distributed random variable x is f x lambda. So when the lambda greater than 0, the customer is the customer arrival rate. Otherwise, there is no customer. So therefore, we're interested in only in the positive part. So furthermore, we find the cumulative distribution function for exponential distribution, which is capital Fx. So you just take an integral. So this actually is the integral Fx dx. And we get the result of u. So u is a 0 to 1 random number. So basically you can generate the capital U from Excel directly. So since in the previous slides capital U is calculated, so we can find an inverse function. So this actually is an inverse of cumulated probability distribution function. So it's an inverse cumulative distribution function, which can also be written as f inverse equals to x equals to this formula. So here u is a random number, so we can generate capital U easily in the Excel. So if you want to generate random variance from an exponential distribution, then this is a formula. So lambda random number divided by lambda, directly from the derivation. So this can also be used for service time, but service time you have a parameter of mu, so you can use a lambda rent divided by service rate mu. So the previous formulas are not important at all, so you just need to remember. So that's how you generate inter-arrival time if the distribution is exponential distribution, and also the service time in Excel. So a screencast is made for the MM1Q example. So you can try yourself and can also check the screencast, and also the solution will be uploaded in the Blackboard soon. So for tool servers example, we also have the simulation model in Excel. So you can try the example, and also you can just watch the video. After we completed the Q simulation part, now we introduce a new type of problem. It's a revenue management problem. Revenue management aims at maximize revenue by efficiently use the capacity, for example, flight seats. So this actually very important problem, because normally the airline's capacity is perishable. In other words, if the flight seats are not sold before the departure, then after the departure the seats just wasted, so it doesn't realize any value. However, the problem in the airlines are always very difficult because the number of reservations, show-ups, and work-ups are normally stochastic factor. The stochastic factors can be actually estimated by probability distributions. Then we can think about a simulation study based on the distributions. A decision is to determine how many reservations the company should accept so that the revenue is maximized. So this is a simple problem. For example, how many total reservation or how many overbook or how many discount customer. So in our problem, we look into only a simple problem. So consider how many overbook seats will be reserved. Apart from the book example, we also provide you one more revenue management example. This example is actually the book problem or exercise. So 10.30 exercise. So if you want to know all the information about the problem or the question, go to check the textbook. Otherwise, these slides will briefly mention what's the problem about. So we have a random demand for a revenue management problem. We have we know how to calculate number of accepted, and number of no-shows is also stochastic factor. The demand is random, and the show-ups equals to accepted minus no-shows. Overbooking is a calculation based on show-ups and the available seats, and the passengers is the minimum value between show-ups and the available seats, total seats. The Excel workbook will be uploaded, so you can try to set up or to solve this model first, and later you can check the screen recording video about the solutions. So this about the simulation. We used 2 lessons to go through the concept and the examples. If you have any questions, please contact me. This is not an easy topic. It needs some time.